Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab, and in the search bar, search maximum depth and hit enter. So there is a question number 104, maximum depth of a binary tree, and it's come under the easy category. So click on it. So let's read the question. Given the root of the binary tree, so we have one function is given and the argument is one argument is being passed, which is root. So root is given. Return its maximum depth. So we need to just return the maximum depth, whether it's 1, 2, 3, 4, whatever it is. We just need to return. So we need to return the integer, right? So a binary tree maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So what is the maximum depth? So maximum depth is the total the number of nodes. Right, total the number of nodes for the farthest leaf node. So this is the one, like 9 is one of the leaf node, 15 is one of the leaf node, 7 is one of the leaf node. So if you consider this 3 and 9, then there are only two nodes. So we can say, okay, depth is 2. But if you consider 3, 20, and 7, there are three nodes. So depth is 3. If you consider 3, 20, and 15, again, there are three nodes. So depth is 3. So the answer is 3. And in this question, there is a constant. The number of nodes in the tree can be 0 as well. So we need to take care of this condition as well, like 0. Uh, if you just look, let's suppose we don't know how to solve the question. Let's suppose, and how we have to solve this question, not via the code, just by looking at the eyes. So by looking at the eyes, what we have to do is, and generally how we are going to find the maximum depth of the tree. So if the tree is small, by looking at the naked eye, we can tell, okay, this is the height of the tree, which is maximum. But let's suppose if the tree is very lengthy, then using the naked eye, it will be very difficult. Then how we are going to calculate manually, not by the code, manually. So manually we will check, okay, we will first check the height of the left tree, and we will check height of the right hand side tree, and whatever the maximum, we are just going to add one, because of the root node, because root is common for the left hand side and the right hand side. All right, and then we are going to return. So the same thing which we have to do. So as an example, so let's put this is a tree. So the it is going to return, but is going to return the maximum height is this path 3, 27, and 15. So how many nodes? 1, 2, 3, and 4. So it is going to return 4. But how we have to solve this question? So there are two ways. One is the recursive, one is the iterative. So let's try the, we will are going to try the both the programs, both the approaches, but first try recursive. So in the recursive way, so let's suppose you are on the root, and you have to tell, okay, what the maximum height. What you will do, you will calculate the height of the left hand side tree, you will calculate the height of the right hand side tree, right? And this will be passed to the root, this will be passed to the root, and the root will be check who is the maximum. Okay, it is returning 1, and it is returning 1, 2, 3. All right, it will check who is the maximum. So 3 is the maximum. It, and the output will be just 1 plus whatever the maximum it's going to return, 1 plus 3, which is equal to 4, because 1 is for the root, 1 is for the root is common. So the same thing we need to do in the recursive solution. So let's try. So in the recursive solution, what we have to do, we have to return 1 plus maximum of left and right. Right? So what we have to return? Return of 1 plus max of, let's suppose we will get some height from the left hand side tree. So left tree max depth, comma, right tree max depth. So let's suppose something will become from the left hand side and something will become from the right hand side. we will calculate the maximum and we are just going to add 1. That is we need to return, right? But what is how we are going to calculate left tree max depth and how we are going to calculate the right tree max depth? So if we have to calculate the max depth of this tree, then this is one of the same sub problem. And if we calculate the depth of this tree, then this is again a same sub problem. What we will do is we will call the same function on this part and we are going to call the same function on this part. All right, so how we are going to do is, so left tree max depth, how we are going to calculate self dot max depth. So we are going to call the same function on root dot left, root dot left. All right, and we will also calculate the right tree from the right hand side, self dot max depth root dot right, root dot right. All right, so we will get something from the we will get something from the left hand side. All right, and we will get something from the right hand side. All right, and while calculating the left hand side we are calling the same function then now, but in this case root is root dot left and in this case root is root dot right. All right, so this is going to call again and again and again. So let's suppose we are on the 20. All right, then 20 is going to call on the left hand side 15 and on the right hand side 7 and 8. Then 15 is again going to call on its left hand side and it's on the right hand side. Left hand side is null, right hand side is null. So if the left hand side is null and the right hand side is null, 15 has to return 1. 15 has to return back to 21 and 20 will add plus 1. All right, so what we have to say, the base condition is, so what is the base condition? The base condition is, because in the recursive solution we need some base condition. If root dot left is none and root dot right is none, it means there is only one node. Let's suppose there is only one node given, only one node given. So root dot left is null, root dot right is none. All right, so only one node is given. Then the output is only one. All right, so the output is 1. So we need to return 1. But there is a one boundary condition as well, because it said there could be something if the root is not given. So if root is none, we need to return 0, because if there is no root, then there is no height. So let's try to run this. So our sample test case has been accepted. So let's try to submit it. So our solution has been accepted. All right, our solution has been accepted. Okay, so this is the recursive solution, which is easy. What we have to do is we will get the height from the left hand side, we will get the height from the right hand side, we will just calculate the max and we will add the plus 1. So we'll get the max of left, max of right, and how we are going to calculate the left, just calling the same function on the left side, just calling the same function on the right hand side. And we are passing the boundary condition. Boundary condition is 1 is the boundary condition. If the root is none, then we need to return 0. And because it is because we have to stop somewhere, otherwise this function is going to call again and again and again. So if once it reaches 9, it is going to call on left hand side, so we have to stop somewhere. So that's why we put the boundary condition. So that's it. And now let's try the iterative solution. So this is the recursive solution. So in the iterative solution we will use the queue. So how you are going to achieve the iterative solution? So in the iterative solution, we need to, because in the iterative solution, like you have to traverse the tree, and to traverse the tree, we have the BFS and the DFS method. Like so, like line by line. So we will come here, we will see okay height is 1. Then we will come here, we will see okay height is 2. Then we will come here, okay height is 3. Then we will come here, okay height is 4. So the same thing we have to do. So what we will do is we will take a queue, and in the starting, we will like store. So first, like we need the we need the boundary condition. If root is none, then return 0. That's it. We need the boundary condition. Then if the root is not none, either it's one node or like more than one node, what we have to do is whatever the first node we are going to store in the queue. All right. So but in the queue, we are going to store the node and the depth. So if we are in the initial, when we are storing the first element, at the time the depth is 1. All right. So that's the same thing we are going to do. So let's take a queue. So let's import that as well. From queue, import queue. And so we have taken a queue. So in the starting, we need to insert the root element. All right. So queue dot put. We need to insert the root. Along with that, we need to insert the depth. So if there is only one element, then the depth is 1. So we need to insert the 1. That's it. Now we are going to run a loop while node queue dot empty. So until the queue is not empty, we need to run that loop. Okay. So till now we have only one element in the queue. So three like only this element, only this one in the like queue. So first we will pop. So if we pop this element, we will get two things. One is the node, one is the depth. Okay. So we will pop it queue dot get, and we will get the node, we will get the depth. All right, we will get the depth. Then we will check, okay, at this stage, what is the maximum depth? All right, so max depth is equal to max depth comma depth. So at this stage we get 1, so at this stage depth is 1, and we will take one element, max depth is equal to 0. So at this stage the like we are going to calculate the depth. Okay, which is fine. Now we will check if whatever the element we just pop, if there is any left node, and if there is any right node. So if there is any left node, we are going to insert, and if there is any right node, we are also going to insert. So 9 and 20 we are going to insert. Along with that, whatever the depth before that, we are just going to add 1, because earlier it's 1. Now on the second stage, it just plus 1. So we will do, so if node dot left, so whatever the element we pop, if there is a left hand side of node, then what we have to do, q dot put, we have to put node dot left and depth plus 1. We have to, and if node dot right, we have to do q dot put node dot right and depth plus 1. All right. So now, so 3 is going to pop. Now we are going to put 9, and we are going to put 20, and earlier depth is 1, and now we are going to add 2. Okay, which is, so now we have, in the queue only these things. So on the queue, so this thing, so we are going to pop. So now we will check, okay, whether the queue is empty. Queue is not empty because there are two elements. So now we are going to pop. So get. So first we will get 9 and 2. Okay. So earlier we store the maximum depth is 1. Now we will check. Okay, what is the maximum depth? Max depth comma depth. So right now 2, and earlier we said max depth is 1. So but now we have updated the maximum depth to 2. Okay. Now we will check if there is any left hand side, and if there is any right hand side. No, if there is no right and left hand side. So this condition has been passed. We will check if there is any right hand side. So this condition has been passed, right? So that's done. Now we will again checking whether the queue is empty. No, queue is not empty. Still there is a one element, because still now we have only popped this element. We have only popped this element. Now there is a one element, 20. Okay. So we will check. Okay, so 20 node is 20, depth is 2. What is the depth? So our max depth is 2. So 2 and 2, like whatever the, here the max depth is 2 and depth is also 2. So max is 2. So max depth is 2. We will check, okay, is there any left element and is there right element? Yes, there are left elements, so we are going to insert. But while inserting, whatever the depth we get earlier, so we get when we like pop 20, we get 2. We have to just add plus 1. We have to just add plus 1. So for 15 and 3 and 7 and 3, then we are going to pop 15. Then we will check, okay, there is no left, there is no right, but the max depth is 3. Now then we are going to pop 7. So when we pop 7, the max depth will be 3. We will check if there is left element and if there is right element. So there is no right element, but there is a left element. So we will get the left element. We will going to insert again. But before inserting, we have to add plus 1 in the depth. So whatever the earlier depth, we will add plus 1. Then we are going to pop. So now we are going to again pop 18. And now the depth is 4. So then again we are calculating what is the maximum depth. So maximum depth is 4. Then we are again check if there is any left element, right element, no. Then we will check, is there any element in a queue? No, the queue is empty now. The queue is empty now. So we will return out of the loop, and we will return out of the loop, and we will going to return max depth. That's it. So let's try to submit the solution. Hopefully it work. Let's try to submit it. So sample cases has been accepted. So let's try to submit it. So our solution has been accepted. So that's it. You can also try the question. It's like it's easy category, and you can also try the both the approaches. One is the recursive and other is the iterative. So thank you.